Hello for everyone. And let's start. Let's start with me. Today I'll talk about infrastructure as a code. So you really, I know that you're familiar with this. What is infrastructure as a code? But I will talk from the Azure perspective. Main idea is to provide for you some additional knowledge, some additional experience from transforming your infrastructure from Azure. As for example, you set up it using the portal, then you need to transform them to some kind of code base. And one of the very known tools for everybody of you is Terrafy. So I will explain how to do it, and maybe you find it some practicals and some practical cases that you can implement inside your project. So let's start. Okay, it's about the Ciklum. Thank you, Leonid, that you told that it's 22 years. Yeah, it's really like a young man who already ended school, who ended the secondary school. So it's cool. And one more thing, 4,000 professionals inside the networking. So if you have any questions, you can ask them inside our professional chats and we will receive an answer. It's brilliant. It's awesome. I don't know, one of the biggest, one of the biggest community that I have ever worked in. So brilliant, nice. By the way, right now we have a lot of different vacancies, and please do not hesitate. One of the slides will include the links for our vacancies. Just push your camera, scan QR code, and apply there. Okay, few words about myself. Thank you that you introduced me previously, but let's deep dive inside my biography. As about the awards, I'm certified Kubernetes administrator, certified Kubernetes developer also. But when I was started in commercial IT, I was started as a Java developer. So my way was from Java to DevOps. And one thing that I need to mention is that if you previously work as a developer, you can understand the developer's lives better. And from the DevOps perspective, you will try to provide as more services for them as you can do. So it's one of the one of the best part from my biography. I also passed in certification from Oracle. It was Java-based certification, but I don't remember. It was like 10 years ago. Linux certification, a lot of different Microsoft certifications, got an MCT award. So let's stop it. Let's continue with our topics. What we will talk about? We will talk about infrastructure as a code. Infrastructure as a code in Azure. It's some difference there, and I will show it for you. And also we will transform some kind of the ARM templates, but let's talk some kind of the Azure resources from real resources that we will deploy together to the Azure portal. We will transform them to Terraform. You will see how it's looking inside the Terraform. Then, as for example, we will run Terraform plan, and we will check that all of the resources is similar. And you can simply transfer this code from one place to another, and it will set up the same infrastructure as well. It's some prerequisites for us. I create for us an GitHub repo. Just please scan this code, go to this repo, run the steps to install such solutions as Terrafy. In brief, the name of these solutions is AZTF eGroup. So please install it. It's several different ways how to do it. I prefer to do it using the Golang script because my second job is like a Go developer. It's really interesting languages, and if you need, we can create some kind of the workshops about it. But right now we are going with infrastructure as a code. So please go inside this repo. Please set up please set up these binaries inside your environment, and let's do it together. It's inside our workshop. Okay, go on. By the way, IaC, do you know it's some abbreviation of infrastructure as a code? So it's approaching how you will manage your data. You can write one, for example, one declarative notification and send this declarative notification to the, as for example, Cloud API, VMware API, different kinds of the APIs. It will get this notification and create for you the several scope of the resources. What it means? It means that if you create it one time, you can set up it everywhere, but you will need to use the same API. It will significantly simplify of setting a large infrastructure, of transferring this large infrastructure from one place to another place, from one data center to another data center. It will prevent some kind of the manual errors, manual faults when you're trying to create. Well known that when you're trying to create a storage account inside the Azure and you doing it manually, it will differ from one place to another place. That's why I'm suggesting to use IRM templates or Terraform to do this. It's only like some tips from my own experience. Also, from Azure side, it's really powerful tool IRM templates, but right now we are not talking about them. Right now we are talking about the transformation. So, additional big part of the infrastructure is the code that it's use some kind of the standardization. If you're talking about the Terraform, it's cloud independent software. It's using Terraform scripts. It's some part of the notifications that transformed from your code. This notification is transforming and then sent it to the Cloud API. Cloud API process them and run to set up infrastructure. Also, if you create your infrastructure, it can be some drifts from base infrastructure to the designed one. So infrastructure as a code also support these drift detections and drift transformations. Let's move on. Which problems it solves for you? Do you know that sometimes when you create some, like to say, base skeleton of your infrastructure, you create, as for example, virtual machines, storage account, some kind of the AP, public AP, that's all. But when developers go inside this infrastructure, what they're doing? They need the backend database, they need some kind of the Redis cache, maybe some kind of the Mongo storage. So they added this infrastructure. And what is it? It will be some kind of the snowfall. So it's and also if they create it manually using the portal, so it's really a big gap. So you don't know who did this. You don't know which version it's using for this IaaS. You don't know which version, as for example, for the Redis cache that they're using. Will be big gap for you. So what you need to do, you need to provide an ability to your developers to create an infrastructure and also to standardize and code this infrastructure in some well-known for you code bases. For example, it can be IRM, it can be Terraform. It's all different things there. It depends which language you're using. As for example, if you're using the Python use different kind of the cloud SDK, so you can just create some simple Python code and declare all of the infrastructure inside this Python code. But it is an example. I don't know which correct one framework or which correct one code codes you are using. So I don't know, but by default, inside the DevOps world, it's several standards. If you want to use some kind of the independent infrastructure as a code tools, it will be Terraform. Terraform supports states, support drifts, support unified deployments. So it's really cool tool sets for us. Let's go on. Benefits. if we're talking about the benefits, do remember that minutes ago I'm talking about the Snowflake. It's a peer, and when it's a peer, you don't know how to fix them. You don't know how to apply these fix inside your environment. You don't know which correct version. You don't know which workloads, for example, for the database you need to use. What you can do if you will create or provide a tool set or some kind of to standardize your infrastructure as a code tool set, it will provide for you like validation and tracking. Also, if you create this infrastructure based on the code and you will need to transfer them, if you will do it manually, you can forget about some environments. As for example, you can forget about the Redis cache, or you can forget about some kind of the network building. It can be everything, but it's a manual fault. So when you create an infrastructure as a code toolset, it will provide for you, and it will reduce the risks of these faults. Okay, what next? When you know which infrastructure you want to use, when you know how many this infrastructure you want to use, you can probably think about how much it will cost, some kind of the fin operations. So in this case, in case of using infrastructure in the code, you will control and maybe decrease your costs. As an example, inside one of my projects, it was maybe 7 or 8 years ago when I was starting as a DevOps engineer, 10 years ago, like this. Development team want to have some kind of the database, and it was system administrator. Remember, he created a virtual machine, set up inside this virtual machine Mongo database, and they continue to use this virtual machine. So when the database increases, they added a new storage. When it's not enough performance, they added some resources. Well, it was, I don't know how to explain it, but from my thoughts, when I provided for them an ability to use Mongo Atlas, it's a managed Mongo cloud solution, they was really happy, because at the middle of this project, the cost for this VM was near 1,200 United States dollars per month. And when we transfer all of the workloads to the Mongo Atlas, cost of this Mongo Atlas, it was like near 400 USDs for our solutions. Yeah, we can increase it really easy from the web interface. So it was a really like cost optimization, some kind of the financial solutions. And also, anyway, just let me notice that this Mongo Atlas database was represented. I created this setup for this Mongo database using the Terraform. Terraform goes inside the Mongo Atlas API and create for us this appliance. Okay, so it's control and don't increase the cost of our environment. That's about the Snowflake. Let's come back to these questions. When you're adding new infrastructure and you don't know what's stored inside the Redis cache, what's stored, for example, inside your MongoDB. Maybe you can reuse your MongoDB, or maybe you can reuse your Redis or some kind of the memcache database. So you don't know. So, and new dev teams, and they know that some Redis cache is using, but they don't know what is inside them. They created a new Redis cache, increase the code. They can't validate who is an owner of this Redis cache. It's a big gap. When you use infrastructure as a code, you can simply describe, I don't know, maybe from Azure side, it's stack used. From Terraform perspective, where you can create some kind of the notice for each of the resources, for each of the models. You can create the models owner as So you can create some kind of a notice, who is an owner and what is the purpose to use this environment. It will help you to validate and track what is used, what and for which reason you're using this part of your infrastructure. And additionally, as for example, how much time for you will take to create an resource using the Azure portal? As for example, the virtual machine. Like for me, it will take like maybe 5-10 minutes. And if I will do it using the API, it will take like 2 or 3 minutes. But if I need to do, as for example, 1,000 VMs, or if I will need to do 1,000 VMs with different storages, so the time will go. It's crazy. I can't imagine. So for me, it will take like a couple days to create all of this environment. But if I will use, as for example, iron templates and run this iron templates in parallel, so I can create this VMs. Maybe it will take for me half hour, or maybe less. So it's speed and efficiency of your work. If you will need to create something using infrastructure as a code, and you will create this using the standardized languages, it's really cool stuff. So next, as an example about this, when I was young and when the tree was more green than right now. So when I started with Terraform, I just wondered why I need to use them, because yeah, it's for me it's more easy to do it using them Azure portal or AWS portal. But then I realized that if it's some kind of the repeatable stuff, for me it's more easy to create some kind of scripts, run the scripts, and it will do the same job that I'm doing. That's what I'm talking. I'm talking about the speed and efficiency of your work. And latest one is consistency. I will not explain because it's really understandable why it's so and why you need to do this. And if you're talking about infrastructure as a code, we are talking the code. So some kind our infrastructure is described. If it, as for example, iron templates, it's some kind of the JSON-based templates. If it some kind of the Pulumi, by default, Pulumi use the YAML definition. And if you're talking about the VMware or some kind of the Hyper-V infrastructure, in this case, we will use an XML. But what's the main things that are inside all of this abbreviation? JSON, YAML, XML. All of them are some kind of the declarative steps when you describe what cloud API, what clouds need to do to provide for you these resources. So you're doing some kind of the instructions for cloud, send them to cloud understands them, and run all of them. Wonderful, easy, and I don't know. For me, it's like predictable models. So when I write something and I know that API and cloud can do this, I post this request to the cloud API, he obtains them and runs them. If you're talking about Azure, mainly it's JSON based, but several APIs right now support YAML. So what you can do is to create YAML, send this YAML declarative notification using the Azure CLI, and it will produce for you necessary steps and necessary environments. Just what you will need to remember from what I'm saying, that Cloud API using the declarative way to create for your infrastructure. If you will need some kind of the additional actions, like I will present these actions inside our workshop. So it's not persistence names or something like this. For this case, you can create a parameter, set it by the parameters, and it will work. But these parameters need to be declared. So the same one, it's declarative languages, declarative parameters. You provide these parameters inside your scripts, and voila, it's appear inside the cloud and it's working. That's gone. We came to infrastructure as a code inside the Azure. Let's see if let's click inside this picture. So how it's all appear? As for example, you trying to create the same one. You trying to create this virtual VM from Azure portal. You added some VMs information like VM name, like in which resource group it will be allocated. This information transformed to the ARM templates, and this ARM templates sent into the Cloud API, and it's proceeded. Azure PowerShell. In this case, it's appearing additional interlayers based on the Azure SDK. This Azure SDK transform your request like to create for you a new resource group. It transforms them to necessary JSON-based templates, ARM templates, and then send them to the Cloud API. But also, I need to mention that inside all of these actions, you will need to pass some kind of the authentication process. In simple words, you need to log in inside your Azure portal. Azure CLI, the same one, SDK. If you're familiar with Azure CLI, like AZ commands, you know that you can create the authentication process based on your shell, like create AZ login. It will redirect you to your browser and then store your authentication information inside the .azure folder. But it depends on your environment. It can be Azure, as I remember, in Windows. Yeah, it's Windows, it's the same. It's .azure inside the Windows. So everywhere it will be .azure. It will store this information inside this folder. This folder is hidden, and also this folder is protected by your local authentication credentials and your local authentication steps. The rest and the same one. When you create some kind of the post request, you can use Cloud API, you can use the Postman, create authentication headers, run this workload using the post request. Voila, it also will obtain by the resource manager and create for you the whole scope of the resources that you need. So, environment lift. I already explained about the environment lift. Yeah, it can be some difference. Okay, colleagues, it's time to practice. It's time to workshop. I already prepared them. Let me open it. I will stop my sharing and share some other browser.
Great. While Leonid is checking his accesses, please check also if you had this downloaded with a QR code that you had. Maybe we can share here just a minute the link if you hadn't. So here we will go with the practical part. So please, Leonid, continue.
Okay, thank you. Here it is. It's a repository created. As you see, it's only like 2 folders there. One of them is picture. This picture is a screenshot of eBPF of this one command. eBPF. -v. I need to mention right now the latest version of the easyTFI is version 0.7. If you're using the Golang can provide it for you in a package with version, as I remember, 0.5. It's the latest stable one version. So please update them to the version 0.7, because as for example, as I know, the difference from version 0.5 and 0.7, when you're creating a virtual machine using the portal, you provide some information about this VM. As for example, as I did inside this ARM template. So let's jump inside this ARM template. It is, I provided information about this VM. So it's an Linux VM that it's using the Ubuntu images. Find them. Some nervous. Where is this? Where is this Ubuntu? Okay. It's admin username. Okay, here it is. So it's an Ubuntu server, and this server is from the image publisher Canonical. And the previous version 0.5, don't know for which type of this VM is belong. Is it belong to the Linux VM or it belong to the Windows VM? So it's can proceed and download the description of this VM and can create for them and Terraform code. So take attention about it. It's one of the difference between previous one version and latest one. And let's go. As we hear, and let's jump back. So I know that you already set up this Azure Terrafy, and you already have the Terraform inside your local environments. I pick up that you already did it, but if you're not, this repository will be open and you can use them. I will leave it as it is, as for example, for 1 month, and I will change the public status of this repo to the private one. Maybe I will continue some additional, like some additional cases that you can use with the Azure Terrafy, and then it will appear to be public again. I will provide a new one workshop. Okay, let's jump inside the infrastructure. Inside the infrastructure, I create for you a simple markdown file with BMD with this wonderful button, deploy to Azure. This button will deploy for your infrastructure. How you can do it? You can simply push this button. By the way, do you know how to create this button? Let me share with you the tricks. Let's onside my Terraform. It's really easy. So what you will need to do, you will need to show where this button is situated, and show what it needs to be done, and which format, which files this will need to take to the deployment process. That's all. Nothing more. Okay, let's jump back to our repository. Let's push this deploy. Yeah, it's custom deployment because I created, as I mentioned previously, each item deployment can be customizable. So you can create this deployment with several dependencies. My deployment have 5 customized resources. One of them is a resource group. It's depend on from the resource group. It's taken a region and applies this region as a default region inside my deployment. It's West Europe. It's want to use an admin username. DNS label prefix is for the connection to this VM. And also it's admin password. From customization part, it's have customization based on the VM size. You can change this size if it's necessary, but by default, I choose one of the cheapest one, just to check how it's working. Okay, and let's deploy it. View and create. Validation path, create. So it takes some time to do this. So let's jump. While it's doing, let's jump inside my deployment. Move out to the GitHub. Let's jump inside infrastructure. Let's jump inside this JSON file, this deployment part. Wow, cool stuff. I made an like big error inside this deployment. It's one of the bad mood from the DevOps practices. So who first blame this code inside the GitHub repo? This person will receive some kind of presence. Olena, will it be so? Yes or no?
Sure. So yeah, let's encourage you to find this bug.
Yeah.
So yeah, the first one who will find it, please write in the comments and we will contact you and you'll receive the branded present from Ciklum. Sure.
So that's
oh yeah,
like that's next step. Yeah, next task for all of the persons. Please find this bug. I know where is it, and you will find it too. But okay, inside these JSON files, I created several parameters, and these parameters has dependencies. Like I said, like I told you previously, it can be customizable. So these parameters need to be customized during the deployment. If you need, please take this like an example for you, but please don't repeat my bug inside it because it's a bad mood from the DevOps practice. Let's back. How to do this button I explain. What's with our deployment? Yeah, it's already done. So inside this resource group, he created for us NSG, he created for us public IP, created for us VM. Inside this VM, he created for us operation system disk, some kind of the virtual network, and network interface. And right now, what we have, we have our Azure Terrafy. I'm inside my folder test activities. What I need to do, I need to create an Azure Terrafy resource group Terrafy because it will contact this resource group and collect all of the resources from this resource group and create for me an Terraform scripts, and then it will run Terraform plan. Okay, let's do it. So it's initializing the resources. In my case, it's initializing the Terraform. It's going inside my subscription using my authentication data that's stored inside my .azure folder. Then it's reading the resources. As you remember, it was 8 resources there, but let's. Oh, sorry, I'm not sharing the correct one the screen. Sorry, let me share full my desktop right now. Sorry about this. It's my bad. Desktop one.
While waiting, we're still eager to have those who will find the bug. So if you already found it, please write in the comments.
Right now, can you see my screen?
Yeah, sure.
Okay, it's nice because let me quit from this. What is that? So, okay, I quit from my Azure Terraform. So let me delete it for everything that was inside this REST group. Everything that was inside this folder. And I will run one more time easyTrafy rg command. And then I need to I need to figure which resource group I'm using. The resource group is Terrafy, so I'm type Terrafy. Voila, it's going. As I told you one more time, as I told you, it's going inside my subscription, installing inside this resource group. It's checking which resources is there, and also it's initializing the Terraform the Terraform model inside my folder. Okay, it's found the 8 resources. 8 items. 2, 3, 4, 5, 6, 7, 8. Starting from 0. And what I need to do? Let's take a look here. So it's show recommendations, W import, S save, QQit, and for the question mark, it's more. What I'm doing, I'm typing the W, and it's downloading and creating for me all of these references. It takes not a lot of time because it's only like 8 resources, but as for example, if you have a big scope of environment, it will proceed more time that is proceed inside my environment. Like it's practically it's ready right now. It's generating for me Terraform configurations. And okay, listen, let's jump inside this test folder and let's see that it's created for us. And it's created for us network security rules. It's created for us public IP, virtual network, subnets, virtual machine, RG. So everything created and placed inside this folder. Question: what is missed inside this? Answer is it's missed models. So yeah, it's true. Azure Terrafy doesn't support the models-based structure. So please be patient about it. I said now the teams that work for the Azure Terrafy right now is working on this model support, and maybe in future versions or inside the release, it will support them. Okay, but let's do the plan and let's check. Does it copy everything or not? Terraform plan. States and time. Yeah, but here infrastructure matches the configuration. So it's just everything inside my local configuration, and everything is working there. For now, do you have any kind of do you have any questions for me?
Seems like the audience is silently studying. So guys, if you have any questions, please raise your hand to unmute yourself or ask them at the chat. Despite the fact that our speaker Leonid actually has the COVID right now, please support him with your questions and your attention. So we are waiting for your remuting yourself or asking at the chat. Anyone? Stanislav, maybe you have any questions to Leonid? Like the experts battle. Let's do it right now.
No, I don't have any questions because I don't like Azure.
Ah, I see.
Stas, that's why I'm here, because I like Azure. And if you have any question about the Azure, you contact me, I'm providing an answer. But if I have any question about the Kubernetes, I'm contacting you and you provide me an answer. This like a mutual help hands, and we help each other, and it's cool stuff.
Yeah, thank you very much for your very cool presentations, workshop. Yeah.
And colleagues, next speaker is Stanislav. I don't know, because some of our American friends call him Stan. Like Stanislav, it's abbreviation of the Stan. I don't know. Is it okay for you? Yes or not? But Stas will continue with his presentations. Stas is one of the famous person in Ukraine who know maybe everything about the Kubernetes. He know everything about the eBPF. Do you know what is eBPF? Stas will told you about this. Why, in your opinion, Azure gains more popularity now? Azure have more popularity because it's cheaper. It's simplest answer. Azure is cheaper, and Azure is right now going with some kind of the aggressive marketing political. So it's like providing an additional resources, providing an additional scope of workloads that customers can use inside them, and that's how Azure take a first place inside the market. But in real life, AWS has more resources. I know about it. Azure is struggling to provide more and more resources. Right now, Azure provides more resources from the machine learning perspective and from the data perspective, because best tool is Data Factory. I don't know the similar tool inside the AWS or GCP, but
yeah, Leonid, also Azure support Windows nodes. They started support Windows nodes in Kubernetes cluster, firstly, this first point, and second, they have very good IoT stack.
Yes, IoT stack is one of the benefits.
Yes.
I had some experience, but best practice from the IoT can be described. Okay, in few words, Event Hub, Notification Hub, it's part of the IoT. Also, it's included inside the IoT Hub. It's provided a quick message senders, message receiving, different queue services inside them. So IoT Hub is the best solution, and like an interlayer between IoT Hub and end user, it provides some kind of the IoT sphere. Like it will be presented inside this Ignite. So like some news from the Microsoft side. Please go inside the Ignite, and you will know more. Also, I want to ask about remote backend, but found an answer. It's cool. It's cool that you can find an answer. Okay, Stas, stage is yours. Guys, please listen carefully. It will be very interesting. Go on.
I don't
Stas.
know, but we will take a look. Okay, good evening, guys. Just a second, I will share my presentation. Good evening, guys. Today we will discuss and talk about very popular words eBPF, Calico, Cillium, CNI. Yes, we will talk on high level, not in deep dive today. Okay. Kubernetes use container network interface. Container network interface is a framework for dynamical configuration network resources. When you create your pods, for example, Kubernetes create pods container. CNI should create network for this container, provide possibility connectivity between pods on different Kubernetes nodes, provide IP address for these pods, and also after delete your container, delete all virtual interface, namespace, etc. Okay, on this slide we can see CNI create a network namespace for container, provide IP address, delete after deletion the container network interface, etc. It is what about CNI? Let's now we will discuss what is eBPF. eBPF is a mechanism for running small bytecode programs in your as virtual machines like Javelin virtual machine in kernel level. On kernel level here. If you worked with FreeBSD, in FreeBSD we had BPF, Berkeley package filter. For example, TCP dump uses a classic BPF, a virtual machine, to select packages and send these packages to user space for analysis. eBPF, it is extended package filter, which migrated from FreeBSD, BSD systems to Linux kernel. eBPF is an extended version of BPF that's suitable for general purpose use inside kernel. Here, eBPF programs attached on different hooks in kernel. Next. Classical for networking in Linux we use NetFilter, and to forward package from network interface to our applications to process or forwarding traffic to another interface, we should pass a lot of steps. And if you have high load traffic and then more 1 gigabit, you will have problems with NetFilter. IP tables use NetFilter. As I said previously, eBPF, it is a virtual machines, but it is not a general virtual machines. Kernel support eBPF, and each version of kernel also support different features of eBPF. And in kernel has a static verificator, verified, and JIT, just in runtime. After creating eBPF program and upload this eBPF program, Linux kernel check verifies your bytecode program, and to possibility have access to memory, for example, to call specific, to allow only specific kernel calls, etc. On these pictures, we can take a look. eBPF kernel runtime. We have kernel helper API, maps. It is eBPF maps in kernel, verifier, and just-in-time compilator. In real life, you will not write by self eBPF programs and deploy in kernel. For CNI container network interface, Calico generate eBPF programs and load these programs in a Linux kernel and attach on different hooks. And for example, you can drop traffic on network interface, not as general via IP tables on user space. After passing a lot of steps, you can drop on network interface. It will decrease load on your CPU, on your kernel for processing these packages. Okay, in user space, SDK, Go, for example, Cillium use Go compilator to build. Also, GZC, etc. We can use. And projects. Cillium they started implementation eBPF, use eBPF in Kubernetes in container network interface. Also Falco, it is security framework, it is a security tool for processing. They can also proceed rules, debug, etc. via kernel. Catran, it is L4, L7 proxy, very fast. And what we can do using eBPF: networking, improve performance networking, security, observability, tracing. In the internet, you can take a look and find a lot of videos with Piotr Zaitsev from Percona. They use eBPF for find bottlenecks with databases, because also they can you can build bytecode program on eBPF and attach on specific hooks, and after that receive these informations. Piotr Zaitsev on a lot of his streams, videos describe about profiling. eBPF provide a lot of options for tracing, profiling, monitoring, security, load balancer, etc. eBPF XDP. XDP is extended data path. In a Linux traffic controller framework, TC framework, was developed for traffic shaping. Currently, we can use eBPF program and attach on a queue disk and also proceed traffic. But pay attention, not all queue disks support eBPF, and kernel provides no op queue disk wallet. Next, express data path. What this means? It is a framework that enables to perform high-speed package processing with eBPF applications. In Kubernetes in general, Kubernetes use IP tables for service. When you create service in Kubernetes, Kubernetes add on each node via kube proxy IP tables rules and route your traffic, balance your traffic via IP tables. IP tables, when you have a lot of pods, a lot of services, a lot of nodes, you will have a bottleneck with performance IP tables. And generally, your package passing IP tables step by step. And please imagine situations. You have the DOS on your Kubernetes nodes, so your applications on Kubernetes, for example, 10 gigabits, 1 gigabits or more. You will have problems with CPU load because you can drop your package only on user space after passing a lot of IP tables chains. XDP provide possibility proceed your traffic on network level. For example, we have a few options. General XDP. These eBPF programs will be loaded in kernel and attached on hook to network interface controller driver, but independent in a kernel. Native. Network interface driver support XDP. And you will proceed your eBPF programs, drop packages, transform, etc. in kernel, in network interface driver, and offload it, XDP. If you network interface says currently support eBPF, Mellanox, Intel IaC, SmartNIC, and a lot of devices for 5G networking. When we proceed, if your network interface support eBPF, you can proceed your eBPF rules on network interface without any loads on CPU and drop traffic on network interface. Using XDP, you can proceed traffic and more than 10 gigabits, 40 gigabits, and 100 gigabits. You can find a lot of different articles, tests in the internet. eBPF data plane natively support in Kubernetes services via AP tables. eBPF provide you following: reduce first package latency for packets to service, preserve external client source IP. If you use standard AP tables in Kubernetes, you will have this issue with preserve external client source IP. Support direct server return DSR for more efficient service routing. Use less CPU than kubeproxy. We tested a lot of different configurations and when we had, but we tested on version 1.8, I had 50 nodes approximately on GK cluster, and I created approximately 500 services with one and also 500 deployments with one pulse. I had approximately 60% CPU load by kubeproxy. When you rapidly create and delete your deployment pods, etc. And kubeproxy use a lot of CPU. If you have a big load DDoS on your applications in Kubernetes cluster, kubeproxy work very, very bad. Community currently discussing moving on IPVS model. Yes, IPVS is workaround, but using IPVS, you can enable IPVS only in self-deployment Kubernetes cluster. Now, yes, if I am right, EKS support enable IPVS. GKE, no, doesn't support. KS, I don't know. We can ask Leonid after after my presentation, etc. Okay. Service-specific monitoring. Monitoring specific process, track, and resources consumption. So you can attach your eBPF programs for debugging, processing, tracing in any on any hooks in kernel. No special instrumentation. You don't need, unlike logs, which typical collect Kubernetes logs, agent, run inside sidecar containers, for example. eBPF works directly on OS level, kernel level, installed by default. Latest kernel, Linux kernel, has model for eBPF. More details and logs, because eBPF program can collect granular process specific data, enable visibility. You can offer greater degree of detail visibility that most logs and metrics can provide using eBPF. A lot currently ecosystems, a lot of different tools support eBPF, and they provide a lot of features with traceability, profiling, monitoring, etc. eBPF in Kubernetes. For example, Cillium, they started to use eBPF firstly. This CNI based on eBPF. Cillium generate for you eBPF program for networking, routing, for servicing, load balancing, network policies, etc. eBPF programs, and load in Linux kernel, attach on as hook on the different syscalls. Pod use eBPF. Cillium provides network policies, service load balancing, works also via eBPF on kernel level, bandwidth management, flow policy logging. Also, you can receive all these logs via Cillium from eBPF, OPSEC metrics. Data path in Kubernetes. What's wrong with the legacy IP tables? I said previously, IP tables run into couple significant problems. Yes, first, IP tables update must be made by recreating and updating all rules on single transactions. Implements chain of rules as a linked list of all operations, standard practice implementation access control list. For example, in Kubernetes, you can create network policies, but if you want to use network policies, your CNI should be support network policies like Calico or Cillium. Calico you can install for network policies as additional network plugin, container network plugin, and Calico will add, update, and delete IP tables rules on each node. And when you have, for example, service mesh like Istio use also IP tables rules for forwarding traffic to sidecar. You have network policies, and Kubernetes also use IP tables for services. And I had a few times situations when traffic stopped, and we didn't understand why this service didn't receive traffic. Why? And we spent a lot of time for troubleshooting. But after reboot all Kubernetes nodes, these problems was fixed. It is not easy to troubleshoot problems with IP tables. IP tables is bad. For high load systems, when you have a lot of big scalable configurations, when you have small configurations to small Kubernetes cluster, you will not have this issue. It's based on the matching IP and ports. Also, IP tables doesn't support L7 rules on application level. Network policies, Kubernetes network policies support L3, L4. What this means? You can filter traffic on port and IP. You can filter traffic, for example, REST API. We will discuss later. Every time when you have new IP or ports to match, rules need to edit and update the chain. Kuproxy earlier updated, generate and update every time all the IP tables rules. Now Kuproxy can update only specific rules, but early, for example, 1.6, 1.8, 1.10 had this issue. Has high consumptions of resources on Kubernetes. These pictures from Cillium articles 2018 year. They describe performance for IP tables. IP tables legacy, for example, can proceed 10 megabits. And NF tables a little more. BP filter and hardware offloaded BP filter can proceed more than 40 gigabits. Now, I saw cases and graphics where guys was able to proceed traffic more than approximately 100 gigabits. I have big experience. I started my career in as a system IT engineer, system administrator in Linux provider. We use a lot of FreeBSD, and from my experience, Linux, FreeBSD can proceed more traffic, yes, but in Linux, when you have more than 1 gigabit intensive traffic, IP tables work very, very bad, and you will have a lot of high utilization, so CPU utilization. eBPF replace IP tables in Kubernetes. Please take a look. We have network interface, physical or virtual device. We can attach our eBPF code programs and proceed our rules, for example, drop traffic or allow traffic on network interface in the kernel level. On next, NAT can send traffic on NAT in pre-routing chain, and put forward and to local our process or forward traffic to another. And also we can attach eBPF code our program. You don't need to attach manually. For you, this implemented via Cillium, Calico, or other programs which support eBPF. But using eBPF reduce speed for processing traffic. You can proceed more speed networking. Next, eBPF. You can create a lot of eBPF programs and pass your traffic from one eBPF program to another eBPF program. But each eBPF program isolated. eBPF host routing, classical, standard container network interface. We have a package, and after that, IP tables, tables and chains. Package, your package should pass it, and only after that you will receive your packets in pods on interface in your pods in network namespace. What about eBPF? eBPF Azure node network interface, eBPF program, host routing, Linux routing, eBPF on your interface. We skipped this long chain IP tables chains. BPF is used by Falco, Calico, Cillium, Facebook, Cloudflare very actively using eBPF, Microsoft, Google, Katran, it is a L3, L7 proxy, developed Cloudflare and Cillium, Netflix, and also a lot of other companies. Networking, observability, security, starting to solve these problems. How to solve? Let's start. Cillium. Cillium is open source software for providing security, observability, network connectivity between containers, workloads in Kubernetes. On these pictures, you can see we have network interface as 0. We have a lot of containers. BPF programs attached on network interface or in a network interface driver, etc. And Cillium daemon on each node generate rules and bytecode programs and inject these programs as eBPF and on kernel level on different hooks. For passing your traffic, for routing your traffic, balancing your traffic via kernel level. Cillium now provide service load balancing, identity visibility, transparency encryptions, scalability, advanced self-service, security, advanced network policies, metrics policy, multi-cluster connectivity, a lot of features. Latest version Cillium 1.12 provide a lot of great features, benefits, etc. Cillium Service Mesh, Hubble, a very interesting tool for observability. Work via eBPF. Hubble install. You should install Hubble on each Kubernetes nodes, and after that you can receive all metrics, a lot of different observabilities in one console. Hubble support a lot of integrations with different tools, and it is also open source product. Cillium CNI networking, network policies, L3, L4, L7 DNS, encryptions, IPsec, WireGuard, load balancer, K8MS, Muggle, DSR, and networking, support IPv4, 6, BGP, overlay, egress, NAT, multi-cluster. Multi-cluster works fine. Using Cillium, it is very easily to create a multi-cluster, connect two clusters with encryptions, etc. But not all work fine. Also, they announced runtime security Tetragon. Also, open source projects you should install on each node, and you can improve security in your Kubernetes cluster in Cillium CNI. Cillium CNI plugin control flow. We have a network interface, Linux kernel with network stack. Yes, we have Cillium plugin, Cillium agent on each Kubernetes node. Cillium plugin create BPF maps and create a bytecode program, inject bytecode program, eBPF programs, and attach on BPF hook, for example, in the Linux network stack. This processing your networking, security, etc. in kernel level, not in user space. IP tables process your IP tables rules in the user space. On kernel level, it works very, very fast. On these pictures, we have two Kubernetes nodes. Cillium connect your pods, provide connectivity between your pods on different Kubernetes nodes, can provide encryptions also. Network models. By default, Cillium use VXLAN encapsulation. This way works fine, but on large configurations, more than 100 nodes, we had a lot of issues with performance networking on VXLAN. Now they fixed a lot of this issue, works fine too. And the second, direct routing. You can use integrate with cloud routers, Cube router, Bird, etc. But you can't integrate with Calico, for example. And you can announce via BGP, for example, on your networking, or connect your networking with external networking. Also, you can. Cillium Hubble. It is full distributed networking and security observability platform for cloud native workloads. Hubble built by and developed by Ciklum and using eBPF. On each node, you should install Ciklum, Hubble, and both this product use BPF. And after that, you can have all observability in Grafana, Prometheus, integrate with different systems. Hubble support user interface, and also you can manage CLI. Network policies in Cillium. This slide is very old. Jerome, he was developer on Docker. He said the problem with IP tables, you can only filter on addresses and ports. You can't filtering REST API. For example, I have applications B or applications front-end and backend. I have different front-end and one type of backend. And the different front-end should connect, for example, on different REST API, do different REST requests on your backend. You can filtering using standard classical Kubernetes network policies. because Kubernetes network policies are based on IP tables rules. IP tables can filtering for only IP and port. Cillium help you with this. Cillium support also L7 applications policies on L7 level, and you can filtering traffic the same way as for Kubernetes network policies, using much label, etc. But specify rules HTTP or HTTPS, method get, post, etc. and pass. And you can filter. Also, Cillium provide for you very good online editor for network policies. It is free. You can use editor and build your network policies in browser with a good usability, testing, etc. Next, Calico. Calico, it is also popular C9 container network interface. Calico support a lot of different Kubernetes clusters, platforms, etc. Kubernetes, OpenShift, Docker, OpenStack, Metal services. Calico use agent on each nodes. Calico exchange use BGP for exchanging routes, for announcing routes, and also with Calico you can export your routes to external. For example, we connected and exported, announced our routes via BGP, and we connected different Kubernetes clusters in AWS and GCP for testing and with dynamical routing. Yes, we had issues with services, but pods were able connect each other in different Kubernetes cluster via VPN between cloud providers. Calico support data plane, Linux standard networking pipeline, Windows pipelines, and also now they support eBPF. Calico support large configurations, large clusters works fine. Calico has control plane, data plane, standard Linux, Windows, eBPF, VPP, pods, etc. When you deploy Calico, you should allocate for each node networking /24, for example. Each node has 24 network subnets, and after that each node announce this subnet and using BGP Calico route traffic. Calico support different types of deployment integrations on-prem, AWS, Azure, Google Cloud. You can take a look. For example, Calico also support VXLAN or BGP routing, etc. Also, you can install Calico, for example, in AWS. Only for processing network policies, Kubernetes network policies, and Calico will edit, delete, and update IP tables rules on each node. With Azure also in AKS, you can find in documentation, install Calico for network policies. Google Cloud also, if you use a standard data plane version 1, and you want filtering traffic, you should install Calico for processing network policies. Calico now support eBPF, but with a lot of limitations. Azure Zero interface, main program, Calico also generate bytecode program, load in kernel, attach as hook, etc. And policy program and connect traffic to pod. The same issue between two nodes. What is the best, Cillium or Calico? Calico work fine on big configurations, 1,000 nodes, 2,000 and more. But do you need Calico or Cillium? Do you need eBPF in your environment or not? Let's discuss. Cillium and Calico, both product has a free open source product version and enterprise versions. Encapsulations and the routing. Calico support IP and IP, BGP, eBPF. eBPF with a lot of limitations. Like Calico doesn't support IPv6 in eBPF and another limitations. Cillium support VXLAN, eBPF, enterprise the same. Support network policies, L4 only, Ciklum L3, L7, enterprise the same. Calico and Cillium store their configurations in etcd. Encryptions. Both products support encryptions, but they have also difference. For example, Calico use WireGuard, and WireGuard has some limitations. Calico will encrypt the traffic between nodes, not between pods, only between nodes. And pods on the same nodes will be will connect each to between without any encryptions. In Cillium, no. Cillium support IPsec WireGuard. For example, Calico support host-to-host encryption for pod traffic. Encryption for direct node-to-node communication support only a management cluster deployed in EKS and AKS, Azure Kubernetes cluster and AWS Elastic Kubernetes service. What about Cillium? Cillium also use IPsec WireGuard, yes. And Cillium provide for you host level encryption, only traffic between two Cillium management endpoints. Pod to pod traffic is encrypted. It is big difference between Calico and Cillium. Traffic between two nodes and traffic between the Cillium management pods and remote currently won't be encrypted. L7 policy enforcement and visibility and eBPF based host routing. Calico has a lot of limitations with encryptions. Also, Calico has a lot of limitations with network policies. For example, only support L3, L4 policies via IP tables, not eBPF on currently. Ingress support. Both product support ingress, multi-cluster. In Calico open source, no. In enterprise, they have these options. And Cillium open source and enterprise support multi-cluster. You can create multi-cluster very easily without any issues. It works fine. We tested different configurations. And your services will be resolved. Will have connectivity between services, etc. Data plan eBPF. Yes. A lot of limitations, as I said previously, doesn't support IPv6, etc. A lot of limitations. You can find this information on Calico page, Calico documentations. I added in this presentation a lot of links. Enterprise support without any limitations, enterprise, and Cillium and Cillium Enterprise support eBPF, but only with one differences. Calico support Windows nodes, Cillium doesn't support Windows nodes. AKS. What about AKS? BPF in testing mode now for enterprise and open source, but it works. We tested, it works. Cillium has some limitations with Azure CNI, with integrations with Azure CNI. I didn't test Cillium with Azure CNI, but according to a lot of documentations, bugs, they have some problems. JKA. Yes, without BPF, Calico only for network policy. Cillium. In GKA, you can create a Kubernetes cluster using a data plane version 2, and this version 2 has some limitations, 500 nodes, but if I am right, Google announced that they will scale it, these parameters for a few thousands nodes per cluster. Cillium Enterprise support without any limitations, but you should install Cillium Enterprise separately. Data plane version 2, it is feature in GKA. EKS, Calico support and Calico Enterprise support for network policies also, but you can also replace EKS CNI on Calico. Cillium also can integrate it with AWS and it works fine. Enterprise support. Both product has enterprise support. Windows nodes, Calico support, Cillium no. Integrations with Istio. In Calico, they describe in documentation, yes, we support enforcing network policies for Istio, but when we tested, tried integrated, we had a lot of issues. With Cillium, Cillium support, Cillium we integrated Istio to proceed policies, Istio policies via eBPF very easily according to documentation steps, and it will be working in eBPF programs in kernel level, works fine. Tested. Observability, Calico open source doesn't have observability any. Calico Enterprise support, Cillium has Hubble. You can install, it is open source product. Cillium Enterprise also has extended features for observability, security, etc. The same with security observability. Calico Enterprise has, Calico open source no. Cillium, you can install Tetragon, open source product for security observability, checking runtime, and Tetragon works also via eBPF on kernel level. Calico is better for performance since it uses underlying networks through BGP. Support network policies L3, L4, high-speed performance, SCTP support Windows nodes. We tested and also I saw very big configurations, more than 2,000 nodes in cluster. It works fine on big configurations. No, doesn't support multicast. Has a lot of eBPF limitations. I added link. You will have possibility to open this link and take a look. Cillium implemented everything via eBPF, work great, has more features, support multi-cluster, can be used with other CNI. Cons may need to be paired with other CNI for BGP, complicated to stop multi-cluster, a little complicated, but according to documentations, it works fine and easily, and doesn't support Windows nodes. You should decide, will you have Windows nodes in cluster? What size of Kubernetes cluster will you have? For example, if you have small cluster less than 100 nodes, Cillium will work fine without any issues on network, etc. Cillium can proceed high performance traffic, provide a lot of security benefits, but Calico work better on big configurations. I saw very large configurations, as I said previously. Works fine via routing, BGP, without VXLANs, etc. But has a lot of limitations with eBPF. For small projects, I will choose Cillium. For big environment configurations, I will take a look what we need to implement, what size, which size we will have, do we need Windows support nodes, Windows containers, etc. And also, if you use management services like GK, AKS, EKS, maybe do you need to install additional Calico or Cillium? They have CNI, and you should decide, should I deploy Cillium or not? Why should I deploy Cillium? Okay, you have some restrictions, security restrictions according to observability, processing network policies. Maybe yes, Cillium will be good, help you. But you will add more overhead for management this Kubernetes cluster. On this page, I collected very popular, interesting articles and links on different documentations box. You can take a look. Also, I can recommend a few very good courses, trainings. First, trainings from Tigera. Calico, they have academy site, free courses, eBPF trainings, very interesting courses. I passed it very easily, and also I refreshed a lot of my knowledge, very useful course. And also from Sol.io, they have trainings, very good trainings related to eBPF. And also after that, you can receive Ciklum certificate and badge on Credit. Okay, thank you very much. You can, if you have any questions after these events, you can ping me in on email or in LinkedIn and ask me. I will try to help you to to speak with you and etc. Now, maybe do you have any questions? Today, we talk only high level because eBPF, it is hard topics. If we discuss eBPF, how to write, how to upload, how to check programs, but we don't need to do it if we use Cillium or Calico. Both this product implemented their features via eBPF. It is transparency for you. Thank you very much. Again, maybe do you have any questions?
Дякую, Станіславе. Якою мовою вам зручніше? Англійською, російською чи українською?
Любою. Можна.
Okay. So what about limitations of the Kubernetes environment? What kind of benchmark you use, and in your opinion, what is the key bottleneck inside the system communication?
I don't remember name of framework, but currently community has a few different tools for testing benchmark. One tools, if I am right, located in Kubernetes repositories on GitHub. Developers use this, and also when we tested, we used iPerf, for example, for tested iPerf between nodes, and also run iPerf in pods on different nodes and tested. Just a second, I will try to find in my notes.
If I understand you right, you're talking about bare environment, bare metal, yeah?
No, we tested in GK, EKS, and bare metal also. In bare metal, you will have more problems. When you use Kubernetes on bare metal, you should also tune system parameters via sysctl. a lot of parameters. When you use Kubernetes in clouds or self-managed Kubernetes but in clouds, maybe you will not tune system parameters. For example, in EKS use nodes with tuned a lot of parameters. GK is the same. They have images for nodes with tuned sysctl parameters for running containers, but for high performance.
Very good. So thank you.
I will add something about the EKS. Not forget, I tested inside Azure nodes. By default, kernel namespace using 4 CPUs inside the communication layers. So it will be some limitations for the traffic, like 5,000 links, 5,000 open ports between ports, and after this, the performance will be degraded.
Yeah, thank you, Leonid.
Great. We have one more question at the chat. So Stas, if they're very limited on CPU on a large cluster, 1,000 to 2,000 of nodes, would Calico work for us?
Yes, Calico. Only Calico will work fine on this configuration, because Flannel use VXLAN, JRE tunnel. Only Calico works on these configurations. I saw configurations.
Kubernetes will work.
Yeah, Kubernetes, yes. Kubernetes, we discussed it, but Calico better because Calico has more features.
And it's provide feature for.
Yeah. Or wait for Flannel with eBPF. I don't believe in this. Currently, we have only 2 network plugins who support eBPF, Calico and Cillium. Calico implemented all their features via eBPF. No, Calico Cillium implemented all their features via eBPF. Calico only data plane.
Great. So are there any questions? Yeah, Virginia got it. Thank you, says. Okay, guys. So also question, did you find the bug in Leonid's code?
I will send now in chat a few links I have found. Yeah.
You did, Stanislav, yeah?
Yes, yeah.
So
You can copy these links. We tested we used a few tools from this list.
Right now, Stas sent for us a link for the testing of productivity inside the cluster, and we are talking about my bug. I did a bug inside my code. Maybe someone found them, or another case, the price will receive by me. Because I know where is it.
Leonid, you will get the present as being a speaker, and Stas as well. So guys, if you found this bug, please write me at the chat right now. If not, there's high time to thank you, our guest speakers, our brilliant ones, for delivering such a great topics, for the high level sharing knowledge. That's really huge. Thanks a lot for your time and preparedness. Also, thanks, Leonid, with this COVID stuff, but still doing your great topic today. And thank you guys for staying till the very end. We were happy to have you all this time and hope you enjoyed this webinar. Stay tuned, as we do those webinars on the regular basis. So speakers, corners from Ciklum are always welcoming you. And have a good and pleasant evening. See you. Bye-bye.
Thank you very much.
Thank you.
Bye-bye.
Bye-bye.